Hi everyone, today we're going to look at two very interesting and I think slightly strange integrals, definite integrals, and I've denoted them here as I and j. Both of them take a complex parameter which I call z. So I of z is defined as the integral from 0 to pi over 2 of sine to the power of z of t over sine to the power of z of t plus cos to the power of z of t with respect to t. J of z is almost the same thing, but there is a cos instead of a sine on the top. Now the reason I'm considering these two things as a pair is because think about what happens if you take I of z and you add j of z. Well, the numerator of your integrand is going to be sine to the z plus cos to the z, but the denominator is also going to be sine to the z plus cos to the z. They're going to cancel, and you're going to be left with the integral from 0 to pi over 2 of just dt, right? This is a very easy integral to evaluate. That's just pi over 2 because 1 integrates to t. Okay, so the reason this is useful is because there's actually a nice relationship between I and j, and you can kind of get a sense that there probably is a nice relationship because sine and cos are very similar functions, right? They're just phase-shifted versions of each other. In particular, I would like to make use of the following relationship, which is sine of pi over 2 minus t is equal to cos of t. Okay, and you can see that, well, in two ways. Firstly, you can just look at the curves of sine and cos and see that one is just like a shifted version of the other, or you can use a double angle formula. If we expand this expression on the left, you get sine pi over 2 cos t minus cos pi over 2 sine t, and because cos pi over 2 is 0, we only get the first term, and sine pi over 2 is 1, so it just turns out to be cos t. Okay, so what I would like to do based on this is introduce a new variable. So I'm going to say let u be pi over 2 minus t. Okay, and we're going to use this as a change of variable in one of our integrals. And when we change our variable, we also have to change the limits. Okay, so let's consider I. Okay, let's just consider I and see what happens when we do that change of variable. So I of z is the integral. I'm going to leave the limits blank for now. So t, well, if u is pi over 2 minus t, then t is pi over 2 minus u, right? So we can write this numerator as sine to the z of pi over 2 minus u. And on the bottom, again, it's going to be something very similar, right? Sine to the z of pi over 2 minus u plus cos to the z of pi over 2 minus u. We have to change our dt into a du, right? And because there's a minus sign in front of this t, du is going to be minus dt, or equivalently, dt is going to be minus du. So instead of du, I'm going to write minus du, okay, because of this minus sign here. We also have to change our limits. So when t is 0, u is going to be pi over 2 minus 0, which is pi over 2, okay? Similarly, our top limit is t is pi over 2. When t is pi over 2, u is pi over 2 minus pi over 2, which is 0. So we get the same limits, but they're just flipped around. Okay, so what can we do with this? Well, there's a minus sign here, and that means we can basically get rid of the minus sign and flip the integration limits around. Okay, so we're going to get, that is the integral, from 0 to pi over 2 of, now I'm going to use this fact that sine of pi over 2 minus t is cos of t, or equivalently sine of pi over 2 minus u is cos of u. So the top is going to just be cos to the power of z of cos to the power of z of u, right? And similarly, we're going to get cos to the power of z of u and sine to the power of z of u on the bottom. All this is with respect to u. And notice that, well, when we add cos to the z and sine to the z, we can add them either way around. And so what we've got here is just the same as j of z. Okay, so we've shown, using this change of variables, that I of z is the same as j of z. So what we can do is then take this result that we derived earlier. Okay, we said that I plus j is pi over 2. And so if I and j are the same thing, then we can write 2I of z is pi over 2, and therefore I of z, which is the same thing as j of z, they're both going to be pi over 4. And there's our result. Now I find this quite surprising, quite strange, that we can put in any complex parameter and always get out pi over 4 as the result for both of these two integrals. So there you go. Hope this has been fun, interesting, and see you again soon.